So question 85 asks us to determine, using this figure, to determine the tension of each cable supporting this load. So, let's check this out. This is really neat. You're going to love this. Now, I got two vectors here. You might not see them. Actually, I got three vectors here. And you might not see them right now, but here are they. I have one
So I go through and I find my missing leg, right?
one vector
Nope,
going
careful,
like
my 9
this.
has to be my C.
So I have this cable that's pulling in that direction. I have this cable pulling in this direction. And I have those two cables are pulling together to equal this direction. Okay? And that, I know the value of this vector is 0, comma, 5,000. Okay? I know this. You might ask, you might ask, how do I know this? Well, I can tell you the direction is straight up in a measure of 5,000 because this gravity pulls down, and it pulls down by a force equal to the weight of the 5,000 pounds. So in order to counteract that, in order to hold it up stationary, it has to be pulling up straight up at the same weight, at the same force, 5,000 pounds. So, excuse me again. So we have a vector pointing straight up, and its component form is 0, 5,000. Now, the nice part about this problem is I know I have that. Let me undo that and make my line a little fatter. I know I have that line that is 0, 5,000. But I also know that the sum of those two other vectors equals that. Okay? So I don't have anything pulling straight up, but I have one cable pulling in the blue direction, and I have one cable pulling in the red direction. And those two things add up to be something pulling straight up against gravity. So that's a sum of three vectors. And this is the graphical representation of that sum. And if I were to superimpose this on a coordinate plane, it would look something like this. And there you go. Now I have a problem that I can figure out. So now I'm looking at my original picture again. And I can tell that this angle right here, let's do it in black, and I don't want it quite so fat, so let me narrow out that line. This angle right here is equal to the same angle done by the two vectors on my previous screen. I can find this angle because I have two sides in a right triangle. So I know that the tangent, let's call this theta. So the tangent of theta equals opposite over adjacent, so 10 divided by 24, and theta is going to equal the inverse tangent of 10 over 24. And we know that the inverse tangent of 10 over 24 is 22.62 degrees. Now, because we know that's 22.62 degrees, I can also say this angle right here that I just drew in, let's call that alpha 1, is going to equal 90 minus 22.62. It really equals 100, so alpha 1 really equals 180 degrees minus 90 from this right triangle right there, and also minus my theta, which is 22.62. So that equals 90 minus 22.62, and 90 minus 22.62 is going to be 67.38 degrees. So theta 1, or I'm sorry, alpha 1 equals 67.38 degrees. Now, why do we need that? Let's go to our next screen and find out. Now, from the previous slide, we had found the angle. We called it theta on the previous slide. I have amended that. I am calling it theta 1. You see a little subscript 1 next to theta in my triangle with the red hypotenuse. And then over here on the blue, the triangle with the blue hypotenuse, I have theta 2 listed. And I've also got alpha 1, which is the far corner of the red hypotenuse triangle, and alpha 2, which is the far angle in the blue hypotenuse triangle. So what I want to do is I really want to find alpha 2, and you're going to see why in a quick minute. So let's find alpha 2. Now, alpha 2, remember the tangent of that, of alpha 2 equals, and tangent is opposite over adjacent, so the opposite side is 24, and the adjacent side is 20. So I'm doing the inverse tangent of 24 over 20. And when I do that, I get, and I need to get my calculator out, the inverse tangent of 24 over 20 is 24 divided by 20 equals, and so alpha 2 equals 50.19 degrees. Now, you're going to ask me, so what? Remember from geometry, if I have a parallel line here, and I have a line bisecting two parallel lines, this alpha 2 is going to be equal to this angle here. So I'm going to label that alpha 2 as well. All right? That is important because when we move our vectors, it will build us a triangle, and we will know the angles of two of our angles in that triangle. All right, so you were wondering why I needed to find that alpha 2 angle, and here's where we bring that. So now I got my theta 1 is 22.62, my alpha 1 is 67.38, and my alpha 2 is 50.19. Now, if I add up alpha 1 plus alpha 2, I get the angle of that angle of the triangle. So if I add those two, I get 17, carry the 1, 5 point, and then 7, and I get 117.57 degrees. Now, remember, this vector is 0, 5,000. What is the length of that vector? Well, the length is, so the magnitude of that vector, we'll call it b, equals the square root, really the absolute value of the square root of 0 squared plus 5,000 squared. which is the square root of 5,000 squared, which is just 5,000. So the length of this green vector is 5,000. Now I have one side and I have two angles in this triangle. I can use the law of sines to solve for the blue side and for the red side now. Because let's find angle beta. Well, angle beta is simply 180 minus 117.57 minus 22.62. And that's going to equal, let me get my handy dandy calculator out, 180 minus 117.57 minus 22.62, and that equals, beta equals 39.81 degrees. So now I can use the law of sines and say, well, the sine of 117.57 degrees over 5,000 equals the sine of, let's find the 22.62 over, and we'll call this B, we'll call this A. So I'm looking for B. And then I can find side B. So to solve for my magnitude of B, I can simply take the sine of 117.57, which is, let's do that, the sine of 117.57 equals 0.886 divided by 5,000 equals, so 0.886 divided by 5,000, and then equals sine of 22.62. Sine of 22.62 is 0.3846 over B. So what that means is 5,000 over 0.886 times 0.3846 equals B. So let's figure that out. So it's 5,000 divided by sine 62. So B equals 2169.4 pounds. And we do the same thing for A. So the sine of, I'm going to show you what I did in the first one a little bit more deliberately here. So the sine of 117.57 divided by 5,000. I'm going to flip these. Divided by sine of 117.57 equals A over the sine of 39.81. And then to get A by itself, see, I took the reciprocal of both the left and the right side of the equation. Now, if I multiply both sides by the sine of 39.81, I get 5,000 divided by the sine of 117.57, and then take that times the sine of 39.81 equals A. And if I do that calculation, I should get 5,000 divided by the sine of 117.57 times the sine of 39.81 equals, so A equals 3611.3 pounds. So the tension, they're not asking for the direction, they're just asking for the amount of tension. So that is a scalar. So we're looking for A is 3611.3 pounds. And B was, what was that again? 2169.4 pounds. And that is your answer.